All right. Now, I can look at this example. All right. So you need to sketch the graph of y equals to 3e to the power of minus 2x minus 5. So let us sketch this graph step by step. First of all, you need to remember which family of the curve does it belong to. E raised to the power of minus 2x, if you remember. Do you remember? So this is, we are going to apply the variations afterward. So the variation is going to be that it is being multiplied by 3 and then being subtracted by 5. First of all, I'm going to draw, I need to sketch this e raised to the power of minus 2x. So can you refer to your notes and see how the graph of e raised to the power of minus 2x was?
Yeah, it was like slightly steep from the left side. Yeah.
Yeah, so if this value of k is minus 2, I would be expecting this graph. Okay. Right now, I'm going to draw the graph for e raised to the power of minus 2x. I'm just drawing a dotted graph because that's not my final graph. This is e raised to the power of minus 2x. Now, what is happening to this graph? It is being multiplied by 3. So, I know that e raised to the power of minus 2x is passing through 1. After being multiplied by 3, where is that point going to be? Every value of the function is going to be multiplied by 3. So even this point is going to be multiplied by 3. So 1 times 3 is 3. So this should be something like this. So my graph is going to be steeper, something like this. Okay, it should pass through 3, but then this graph has to be translated downward by 5. So where do you think this point is going to go?
So would it go to -2 then?
Yes, it is going to go to minus 2. Acha, one more thing. I know that over here this graph was asymptotic to the x-axis. ठीक है? यानी कि this line was y equals to 0. यानी कि y equals to 0 के ऊपर मेरा graph end हो रहा था. तो यहाँ पे when it is going down by 5 units, where should this asymptote go? Would you agree that this also is going to go down by 5 units? So at minus 5, this was the asymptotic line. Previously, the x-axis was the asymptotic line. Now, since the entire graph is shifting by 5 units downwards, so this asymptotic line is also going to shift by 5. And as you said, it is going to pass through minus 2. So the general sketch is going to be something like this. Just wait, just wait for Azan and then.
Okay.
All right. So this was one way to sketch in parts, but in exam you might not be having so much time to first sketch e raised to the power of minus 2x, then times it by 3, and then subtract 5 from it. So instead of like doing like this, the better way would be to do some calculations and do it. Can you hear me properly?
Yeah, sure, I can hear you.
Okay. So all you just need to do is remember the sketch of e raised to the power of minus 2x. Okay. First, let us do some calculations. So if you are going to increase the value of x to infinite, okay, positive infinity, let's say you are
Yeah,
going to increase the value of x to positive infinity, you are going to take very 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 large value, what will happen to the value of the function?
so it increase.
It is so your y is basically equal to 3 e to the power of minus 2x minus 5, which is same as saying 3 divided by e raised to the power of 2x minus 5. So when your x is going to approach a very positive value, very high positive value, your denominator is going to be your denominator e raised to the power of 2x is going to approach to positive
Yeah,
very high value. Okay,
yeah,
so I can say that it is going to reach to infinity. So if that is the case, then 3 divided by infinity will approach to any number divided by infinity is 0.
0. Okay.
So y is going to approach minus 5.
Okay.
Okay, so this
Oh,
tells me one thing, that my asymptote, as I'm going to increase the value of x, the value of y is going to increase to minus 5. And then you can look at what will happen if you take the values of x in the other direction and you increase it to minus infinity, let's say. Okay, if you increase it to minus infinity, what will happen? So y is equal to 3 divided by e raised to the power of 2x minus 5. Now notice this, that as you are going to decrease the value, as you are going to decrease the value of x to negative infinity, okay, I'm going
yeah,
to decrease, as I'm going to decrease this value of x, this number is going to be getting smaller and smaller and smaller and smaller and smaller. This number e raised to the power of 2x is going to approach 0.
yeah.
Okay, so what is any number divided by 0?
Um, isn't that infinity?
Yes, so this means that the entire fraction is going to reach to infinity. Okay, it is going to reach to infinity. Now infinity minus 5 is also infinity.
Okay.
So now I can understand the trend, that for the positive values of x, the number is approaching to minus 5.
Yeah,
Okay, and if I keep on decreasing the value of x to a negative value, the number is increasing to infinity, so I get to know the shape. Now I just need this x-intercepts and this y-intercept. So what I'm going to do is, for the x-intercept, I'm going to take plug y as 0. And if you remember, we now know how to solve this equation, or you can simply solve it like this. E raised to the power of minus 2x is going to be 5 upon 3. You can take ln on both sides. So can you solve this and give me the value of x?
yeah. Minus 0.25.
Minus 0.255. So x comes out to be minus 0.255. So now I know the x-intercept. Let's find the y-intercept. The equation is same. Y is equal to 3 e raised to the power of minus 2x minus 5. For y-intercept, I know what I am going to do.
So you can take x as 0.
So when I put x as 0, would you agree that I'm going to get 3 e to the power of 0?
Yeah.
And what is this number going to be?
Minus 2.
Minus 2. So now the results are confirming to the our solution. When we were doing the previous method, we knew that it is going to intersect at -2 on the y-axis. So this is -2, -3, -4, minus this is -5. So I cannot go below -5, and the shape is going to be something like this. It needs to be a freehand sketch, and I know very well this point now. This is going to be -0.255. Okay, so that is going to be the sketch. So this is how in exam you are going to sketch.
Okay.
Let me know when you're done.
Yes, sir. Copy that.
Oh. Now let's say you have to sketch the graph of y equals to 4 ln 2x plus 5. Okay, so what am I going to do? I'm going to find the x-intercepts, the y-intercept. This is ln graph. So just always remember the basic sketch of ln. That was this. Now, what am I going to do now? I'm going to find the x-intercepts and the y-intercepts first. So when x is 0, what is y coming out to be?
6.43.
6.44 around. So roughly 6.4. Okay. But the exact value will be 4 and then 5 if they ever ask you for the exact value. So when y is 0, what is x going to be? So you are going to convert it into an exponential equation. E raised to the power of 0 is equals to, अच्छा सबसे पहले हाँ e, what you can do is 0 divided by 4 is going to be 0 ln 2x plus 5. E raised to the power of 0 is going to be 2x plus 5. So what this x comes out to be? So x comes out to be -2. So this means that the graph is going to intersect the x-axis at -2. Acha. Now, if I ask you for what value of x is this ln function defined, because there is a restriction on ln function. So for what value of x is this ln function going to be defined?
-5.
If you ever want to check for which values of x is this function defined, you are going to take the inner term, that is 2x plus 5, and you need to remember that condition, that whatever is inside bracket, it needs to be positive, because ln of a negative number or 0 is not defined. So this value must be greater than 0. So this means that x must be greater than minus 5 by 2.
So can you say that again?
Yeah. If you want to check whether for what values of x is this function defined, I'm going to take the inner terms inside the bracket, inner expression, that is 2x plus 5, and I would set it greater than 0 because inside bracket the term cannot be negative.
Okay.
So what 2x plus 5 must be a positive value, it must be greater than 0. So
Okay.
x must be greater than what?
So greater than 0 then.
X 2x plus 5 must be greater than 0, so x must be greater than.
So it has to be greater than 0, right? For it to be positive.
No, I'm saying that if I know that 2x plus 5 is greater than 0, then x must be greater than minus 5 by 2. If I'm going to solve this linear inequality, this is going to result in a value of x that is greater than minus 5 by 2.
Oh, okay.
So x must be greater than minus 2.5. यानी कि 2.5 minus 2.5 से ऊपर जितनी भी values होंगी, they are going to satisfy the equation. Below x की values that are below minus 2.5 are not going to give you the uh, your function is not going to be defined at that point.
Okay.
So this means this value is going to help you in identifying the asymptote line.
Okay.
Okay. Then you need to understand the shape. So what will happen as x increases to positive infinity? If you keep on increasing the value of x over here, what would happen to your function? If you
So
take a
it would,
very large value of x, what is your y value approaching will approach to?
so y would go to infinity then.
Yes. So it means that when the x is increasing, y should also be increasing. And when x is decreasing,
So y would go to 0 then.
acha, the minimum value, I cannot take minus infinity over here because x is greater than minus 2.5. So if x is approaching minus 2.5, what do you think y is going to approach to? You can try plugging in minus 2.5 over here, okay, and you are going to get what is your y value going to approach to. So यहाँ पे when you are going to plug in minus 5 by 2, would you agree that you are going to get a 0?
Yeah.
So that is undefined, right?
Yeah.
Yeah. So your basically what will happen is your value is going to go towards negative and infinity. Because if you take, let's say, minus 2, minus 1 point, or minus 2.4999 as well, what will happen is that your value of the function is going to go further negative. So based on this information, I'm going to sketch my graph. I know that the asymptote line is going to be occurring at
Minus 5 upon 2.
minus 5 upon 2, which is this point. Okay, so this means that my graph should be ahead of this, and as I am going to increase the value of
Sir,
x,
are you drawing something? Because the screen's frozen.
yeah, I was trying something. Just give me a second.
Yeah.
Okay, right?
Yeah.
So
No.
now your sketch is going to be something like this. The value of the function is going to increase. With the increase in values of x, your value of y is going to increase higher and higher. And with the decrease in value of x up to minus 2.5, the value is going to go further down negative.
Okay.
So, and what is this point going to be? Minus 2. And this point is going to be 4 ln 5 or 6.44. Okay, this is how you are going to draw the sketch. let me give you some questions so that you can sketch. Say, sketch these functions out.
So I'm a bit confused on this one.
Okay, which one? The exponential one or the log one?
The exponential one.
Okay. Now we just need to draw a sketch. Our sketch doesn't need to be the accurate sketch, but it should reflect the true graph. So the basic thing, you're going to find the y-intercept and the x-intercept.
Yeah.
So when you are going to take x as 0, you will get y as
1.
1, right? So this is going to be 1.
Yeah.
So the y-intercept is 0 comma 1.
Yeah.
Okay. Now when y is 0, x is going to be
0.173.
so minus e to the power of 4x plus 2, e raised to the power of 4x equals to 2. I'm going to take ln on both sides. So x is going to be ln 2 upon 4,
Yeah.
0.173. Okay. Now let's recall the shape of this graph. If you remember, this was e raised to the power of x. For e raised
Yeah.
to the power of 4x, the sketch is going to remain look like same. It's just going to be steeper, but it is going to be same. But with that minus sign, it is going to flip downward. And then in this graph, 2 is going to be added. So this graph will further go up by 2 units and your shape is going to look something like this. Now, so we are going to, like, you can always understand the graph like this, that when x is going to approach a very very high value, what will happen to the value of y over here? So this is, so as x approaches a very
Yeah.
very high value, e raised to the power of 4x is going to be a very, very high value.
Yeah.
And if I multiply it by minus, then it is
Negative.
very, very negative. Okay.
Yeah.
And if in negative infinity I'm going to add 2, that is still going to be negative infinity. So
Okay.
this means that the graph approach goes downward like this, as we mentioned. As you
Okay.
increase the value of x, the graph is going to go down. Now as x approaches negative infinity, okay, so what will happen to the graph? If you have a very, very small value of x, then this is going to be going closer to 0. Okay, yes or no?
So can you say the last thing again? I don't understand.
Yeah, I was saying that if x has a very, very small value,
Yeah.
then e raised to the power of 4x is going to be very, 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 very small,
Yeah.
which means it is going to be closer to 0.
Okay.
So if this number is closer to 0 and you add 2 in it, so this y value is going to approach to 2.
Okay.
Okay, so
Okay.
this will show you the trend of the graph.
Okay.
So the maximum value I'm getting over here is 2, and the x-intercept is 0.173 and the y-intercept is 1. So 0 comma 1 is this point, and the x-intercept is 0.173. So the shape of the graph is going to look something like this. Okay,
Yeah.
now try 4 ln 2x minus 4.
When finding out the y-intercept, it's coming not 0. So what value would I take for that?
Okay, so one thing we know, the first thing that you can think of it is that this value, for what values of x is this going to be defined? So 2x minus 4 must be
2.
greater than 0, so x is going to come out to be greater
2.
than 4 upon 2, that is 2. So your vertical asymptote is going to be made on x equals to 2. The next thing is for the y-intercept.
Yeah.
Sorry, for the x-intercept, you're going to take x as 0. So 2x minus 4, okay, and this is going to be 0 equals to ln 2x minus 4. E raised to the power of 0 is 2x minus 4. 1 equals to 2x minus 4, and x comes out to be 5 over 2. Agreed? यहाँ तक ठीक है? Now, the reason you're getting mass error for the y-intercept is because your curve is not going to cross y-intercept, because you're going to have values of x that are greater than 2. This is going to be your asymptote. So your entire sketch is going to be beyond 2. So you are not going to have the y-intercept with you, okay? And this is going to be 5 over 2, that is 2.5. Make sense? And you can
Okay.
do the same
And
working that, sorry,
when finding out the intercept, like how do you put e to the power 0? Wouldn't that equal to 1?
yes,
I'm a
e
bit
to the power
confused
of
with that
0
part.
is 1. 0 divided by 4 is 0. E
Yeah.
to the power of 0 is 1.
Oh,
Okay.
okay. Sir, are you saying something?
No. Can you hear me now properly?
Yeah, I can hear you now.
Okay. Now, do you understand sketches or do you need some more practice?
So if you could do more practice, because it's a bit confusing.
Okay. Which one is more confusing? Is the exponential equation more confusing or the log equation?
I think the exponential one.
Exponential. Okay. Okay, draw all these graphs together so that you have a clear understanding. Okay, these are the three graphs.
Sir, it's coming maths error on the y-intercepts. That means it's not going to pass by it, right?
Yes. So you are saying that the y-intercept is coming to be maths error, which means y-intercept is not coming. So for y-intercept, you are going
Not
to uh,
x-intercept.
x-intercept. Okay. So for x-intercept, this is going to be the case. So e raised to the, this is going to be minus 4 equals to 2 e to the power of x. E raised to the power of x is going to be equal to minus 2. And yes, now that's not true. Okay. Because e raised to the power of x is always going to be above 0. It is never. So no x-intercepts. Yes. So this means that the curve is going to lie entirely above the x-axis. So what is the y-axis, y-intercept coming out to be?
6.
6, yes. So when x is 0, y is 6. Now, do you identify the sketch of this? It's simple, e raised to the power of x. So e raised to the power of x should be,
Then passing through the point 1.
okay, but hmm. So what is going to be the asymptote over here?
Would it be 4?
Previously, when I draw e raised to the power of x, the line, the x-axis is the asymptotic to the curve. Now, if the curve is going to shift 4 unit upper, the asymptote line is also going to shift 4 unit upper. So it is going to go to 4. And then you are going to have a graph, have a sketch like this. But this point is going to be 6. Okay?
Oh,
Do you understand this?
yes, sir.
Okay. Try the other one. Now the other one is e raised to the power of minus x.
So, sir, will it be above 7 on the y-axis and pass through 8?
Sorry, what you are saying?
Would the graph be passing through 8 as the y-intercept and the entire graph would be above 7?
Let's find out. So when x is 0, okay. So what will be the y value? 2 e to the power of x plus 6. When x is 0,
Yeah,
this is going
y,
to be e raised to the power of 0 is going to be 1, and the answer is going to be 8.
yeah,
Okay. If do you remember e raised to the power of minus x graph? E raised to the power of minus x looks like this. Okay. So that is going to be the general shape of the graph. Okay. Yes or no?
Sir,
I'm saying that e raised to
sir,
the
I
power
can't
of,
hear you.
yeah, can you hear me now? Can you hear me now? Hello? Can you hear me now?
Yeah, no, I can hear you.
Okay. I was saying that you need to remember the basic sketches. E raised to the power of minus x would look like this. It is going to be the reflection of e raised to the power of plus x in the y-axis. So this is going to be the shape of e raised to the power of minus x. It is going to pass through 1. Now it is now the shape is going to be similar, but it might pass through some other point because the equation is different. So yes, the y coordinate, the y-intercept is 8. What other query were you facing?
What, sir?
Was there any other problem in sketching?
No, I was asking that will it be above 7 on the y-axis,
It is going to be above 6.
like intersecting through 8 but above 7?
It is going to be above, well. It is going to be above 6.
Above 6.
Okay.
Okay.
Yeah. So let's say this is 6. The entire graph is going to be above 6 and will have a shape like this. And this point is going to be 8. And you can see it's not intersecting the x-axis because it is above, way above the x-axis. Okay, are you doing the last part? Are you trying the last part?
Yeah, I'm trying it. So I'm getting confused if this one will look like the y equals to e to the power kx or y equals to k e to the power x graph.
It's both.
Okay.
Basically, this is both. So if you remember, e raised to the power of minus x is going to look like this, okay? E raised to the power of minus x. But once I'm going to multiply it by minus 2, it's going to be reflected in the x-axis. So this is going to be after the reflection. So something like this, okay? And yeah. So these are the this is the information that I have found. I have
Yeah.
found the x-intercepts, the y-intercept, and the general trend of the graph. So I know that when it is going to approach a very large value, so the maximum value of y is going to be 4. When it's going to approach a very minimum value, so it is going to approach negative infinity. So this tells me that the graph should look something like this. This is going to be plus 4,
Yeah.
and the x-intercept is minus 0.693. Okay, the general trend is going to be such that when you increase the value of x, it approaches to 4, and when you decrease the value of x, it approaches to negative infinity. So the trend is going to be something like this.
Okay.
Do you get it?
Yeah, sir.
Okay, so I can give you some questions for homework,
Okay.
and those remaining questions can be done in the next class. Acha,
Okay,
the
sir.
screen is frozen, right? The screen is frozen. You didn't get to see the graph. Just give me a minute.
The last one is not
Yeah, yeah.
there.
I don't know why my internet is lagging so much today. Let me share the screen. Okay, yeah, you didn't get to see the graph, right? This is the graph.
Okay.
Please
Passing
draw
through
this.
to where?
Passing through. Oh, yeah, yeah. This point is going to be 2. Yes. Oh, sure.
Yeah, I've drawn it.
Okay. Now I'm giving you some graphs for Ellen.
Okay.
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 So you can try on these graphs and let me know by the next class.
Okay.
All right. Thank you.
Okay. Thank you, sir.